Hey guys, Rhett here. Today I have a worded problem for you. So the dimensions of a farmer's sheep enclosure are shown on the right. We see in yellow here the fences and some of the dimensions are given to us. The first piece of information we're told here is that the perimeter of the enclosure is 80 meters. So for part A, we find the rule for the area, A meters squared, of the enclosure in terms of x. So the first thing I will do, using the information about the perimeter, so the perimeter is equal to 80, which is equal to, now I simply add up all of the side lengths. You'll note over here that the perimeter of this side here is going to be x minus 5 meters, and the perimeter of this one here, this side length, is going to be y minus 10. Okay, so when I add up all the sides to give me the perimeter, x plus y plus, now I just put in brackets x minus 5 here, plus the next one, y minus 10, plus 5, plus 10. I'm going to neaten all of this up, and I get 80 is equal to x plus x is 2x, positive y and another positive y, plus 2y, negative 5 and the positive 5 are going to cancel, negative 10 and the positive 10 will cancel. Okay, so I'm left with 80 equals 2x plus 2y. X plus y is equal to 40, which then implies that y is equal to 40 minus x. Okay, and now for the area. The area is going to equal, imagine I take the full block, which would usually be x times y as a basic rectangle, and I'm going to subtract what you see here, this block. So you essentially want to delete this one. So we're going to subtract 5 times y minus 10. So that is going to equal xy minus 5y plus 50. Now, in order to get a in terms of x only, I'm going to substitute this piece of information that I figured out earlier, y is equal to 40 minus x. I'm going to substitute that into here. So a in terms of x only, wherever I see a y, I replace it with 40 minus x minus 5, 40 minus x, and then you've got the 50 in the end. That is equal to 40x minus x squared minus 200 plus 5x plus 50, and collecting all the like terms and reordering them. Negative x squared, 40x and the 5x, positive 45x, negative 200 plus 50, negative 150. Okay, so that is part A solved. Now, a suitable domain for the function a of x, part B. So this is a physical problem. We have physical gates being built here, or physical fences for the enclosure. This component here is saying x minus 5. If x was equal to 5, this would be 0, so I can't have that. So x must be greater than 5. I have the dimension y, which was equal to 40 minus x. That then implies that x must be less than 40. Because if it was greater than 40, it would turn y dimension into a negative value. I can rewrite this dimension here as dom A equals curly bracket 5, so not including 5, to 40. C, find the maximum possible area of the enclosure and state the corresponding values of x and y. So for part C, now you'll observe that this graph here, a of x, is essentially a parabola. It's a negative or an upside down or a frowning parabola. So in order to find its turning point, its maximum is located at negative b over 2a from its generalized form. So the x-coord is equal to negative b, negative 45, over 2a, which is negative 2. So we get a positive 22.5 meters. In order to get the corresponding area, so the area when x is equal to 22.5, we would substitute that back into this original expression here. And using your calculator, you would attain the value 356.25 meters squared. And if you wanted to work out the corresponding y value, y would equal 40 minus 22.5, and that would give you 17.5 meters. Part D is the sketch of the graph of A against X, showing all key features, turning point, and axes intercepts. So I'll just move over to this other page where I've done this sketch here. So this is the graph of f of x is equal to negative x squared plus 40x minus 150. X-intercepts of this graph, I'm solving the equation a of x is equal to 0. So I essentially solve x squared minus 45x plus 150 is equal to 0. Gotten rid of that negative sign. To solve this, I'm going to use what's called the quadratic formula, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to give me 45 plus or minus the square root negative 45 all squared minus 4 times 1 times 150 all over 2 times 1, 2a. So at this point here, you'd use a calculator to help you simplify it down. 45 plus or minus the square root of 1425 over 2. And approximating that, x is approximately equal to 3.625 or 41.375 meters. So the x-intercepts, if I round to 2 decimal places, 3.63, 0 and 41.38, 0. If I go back to my graph here, just to point out all of the key points, I have the left x-intercept here, 3.63, 0, the right x-intercept at 41.38, the turning point, which was up here at 22.5, 356.25, so that was a maximum area, and an intercept down here at negative 150. Now remember from before, the domain was restricted between x equals 5, so I'll just draw that line there, and x equals 40. So I'm only interested in the graph between this point here with an open circle, not including this point, all the way up, find its maximum, and then back down here to when x equals 40, not inclusive. You'll find that when you substitute in those values, when x equals 5, the graph is equal to 50, and a of 40 is 50. On the last part E, state a suitable range of the function. That the range of a of x, so we go from the lowest point here at 50, not inclusive, all the way up to its maximum up here. So the range 50, not inclusive, $356.25 inclusive. Thanks for watching, guys. Feel free to like and subscribe, and good luck with methods.